All right. People in the back, can you all hear me? I assume people can hear me. I think we're ready to get started here. Well, first and foremost, I wanted to start out by just thanking all of you for being here. I realize this is the last day of the conference, first talk session of the day. It's early in the morning. There are a lot of other places you could be spending your time, whether that's at one of the other great options for talks happening concurrently with this one, or whether it's just sleeping. So yeah, once again, thank you all for being here. If you'll humor me real quick, I'd really like to start out by summarizing the goals of this talk in the form of two memes in graphical form, and a little bit of audience participation just to make sure we're all awake, especially myself. So could I get a quick show of hands? Who has been in this situation before, where you have a feature on development, it works on your laptop, but it doesn't work on prod when you deploy it? Okay, yeah, a lot of people. It's a common situation, and for those of you who didn't raise your hands, is that because it always works on prod, or is that because it also doesn't work on dev? Okay, so this second meme I stole from someone on the internet. Legend has it that one day a wise individual or set of individuals decided, okay, you know what, we'll solve that problem by just shipping your laptop to prod, and then it'll work there. And thus, containers and later Docker, Kubernetes, and so on and so forth were born, and that solved a lot of problems around this space, making sure that it doesn't work on dev, but fail on prod. But there's still a problem that remains as it pertains to the data, your database. Things can still work on your laptop, but fail in prod, because your laptop's copy of the database might be different for a number of reasons than what you see in prod, and that can result in a lot of bugs, whether that's performance or functionality. And so that's really the motivation of today is there some way for us to solve this problem, do what Docker did for the application layer, but for the database? So before we get into thin cloning specifically, and how that's been so transformative for us at Academia in tackling this problem, a quick introduction about myself. Hello, my name is Nick Meyer. I am a staff software engineer and team lead of the platform engineering team at Academia. Academia.edu, who are we? Since maybe some of you have heard of us, maybe most of you haven't. We are a startup based in San Francisco in the US, and our mission is to accelerate the world's research. How do we do that? 2 words, open access. The whole idea of our platform is if you are an academic, you can sign up for our site, upload the academic work that you have published, and we will make it available for free for everyone to read all around the world. Or alternatively, if you just want to check out cool research, you can sign up as well. What is that QR code in the corner? If any of you want to scan it and find the slides. I feel a little bit like a podcast host here. You know, slides are available wherever you get your slides, whether that's the conference website for this talk, or whether that's that QR code, or if you want to type in that URL. Don't worry, the QR code will remain. I'm going to move on to the next slide. So on the platform team, a big part of what we do is figure out how to, make devs happier by improving the developer experience, and also how to, in doing so, speed up engineering. That's a big part of our team's mission, and I've been a Postgres user for a little more than 7 years, which, compared to some people in this room, that's not a very long time, but needless to say, I really love working with Postgres. I think it's great. Maybe you're saying, okay, you're giving a talk at a Postgres conference, you're biased, right? Yeah, obviously I'm biased. I think a lot of the people in this room are biased, but don't take my word for it. Here's a screenshot of the Stack Overflow developer survey for 2025, where we can see Postgres in terms of adoption as a database in your organization. It's only grown its first place lead over time. So in my somewhat biased, admittedly, opinion, using Postgres in the first place in your organization is a great first step towards a great developer experience as it pertains to the data layer. So how can we make it even better? Let's talk a little bit about the dev env struggle, as I call it, in greater detail. So what are some Development data difficulties you may run into. Well, you have some choices to make in terms of architecture. Do you have a shared database? Do you have multiple databases for devs? I'm guessing we have multiple, like everyone has their own DB in their own environment, at least before we did thin cloning as the alternative. And there are like different trade-offs with both of these approaches. Shared, it's a little more manageable for the platform team that needs to make sure the schema is what it should be. Migrations, data migrations, changes need to happen, but obviously we don't want devs stepping on each other's toes. So if you have many DBs, that's a little bit better, but the trade-off there is that everyone on their own needs to apply schema changes, and this can cause some struggle. They ask for us for help on the platform team. Schema, table definitions, indexes, do they exist or not? Partitioning, this can be different for a number of reasons, whether intentional or not. Over time, this drift will grow between development and prod, in my observations. There's this theme of, is the data realistic enough to be useful for development? We're a Ruby on Rails shop. There's this thing called factories where you can generate, or it's supposed to, if it's working properly, it's supposed to let you generate realistic looking data, preserving all referential foreign key relationships properly, but it's hard to maintain, it often breaks. The approach of subsetting the data, anonymization, also kind of difficult. And lastly, there's this issue of scale. Even if you do everything that I mentioned previously perfectly, 100% correct, how can you possibly make a 1 megabyte development local database properly capture everything there is observable in this world about a 10 terabyte database? And, suppose you have some users on your site who have just tons of uploads, and you didn't imagine this scenario in development. That's another thing that's on this theme of scale. So left unchecked, what does this result in? This results in a situation where I'm going to call it just team 1 as a placeholder. Let's say you have this team 1. They've worked on this feature for the past 3 quarters, and if anyone else in the engineering organization wants to test out anything they've done in development, they need to follow this long checklist that's documented in Markdown, exclusively buried in this Slack thread, or maybe a GitHub issue, or dare I say like a Jira ticket somewhere, which is not like the greatest experience if you want to know what's going on in the rest of the org. So some of you might be thinking, okay, what about a staging environment? Does that solve some of these problems? Could this serve as sort of a bridge in between development and production and the differences that exist therein? In my opinion, staging has a lot of the same problems as development, and then some on top of that. Staging is frequently, at least in my organization, maybe it's different in some of yours, it's frequently a target of cost cutting, where we introduce these intentional differences with production, such as, what do you mean you want to store the 10 terabytes in staging? We're not even serving traffic off of that. So, we need to have a smaller data set, and we run into the same problems. We also have a shared DB here, since we're not going to have an expensive real database in staging for every single developer, because we don't want to pay for staging. And also, when staging breaks, who fixes it? More maintenance burden for the platform team. And so the result of all of this is that if devs can't get what they need for all the reasons I have mentioned before when developing new features, they fall into this anti-pattern where people test in prod. Now, why is that bad? I'm not ideological about that. I don't have a visceral reaction when I hear test in prod. I think of the reasons, and I think there's 2 main reasons why testing in prod is bad. One is that it's slow, it's time-consuming. 2 is that it's risky. It's risky both in that you might break something in production, and that's bad and stressful to fix. And also it's risky if you have sensitive data, PII, to potentially be exposing that. So what do we want, in summary, to solve these problems? Well, I'd say if I were to distill 3 properties that I would really want for development, I would really love if there was some option to have a database that didn't cost a lot of money, was low maintenance to maintain, that matches prod, ideally perfectly. Now, some of you may be thinking, okay, do we want it to really match prod? I thought you just mentioned PII and sensitive data. Maybe some of the columns shouldn't quite be the same. Do keep that thought in the back of your mind. I'm going to address some strategies for this at the, closer to the end of the talk. For now, maybe just assume we have a database. It's not Subject to those constraints, we have the PII in another database. We'll deal with that one later. So does some solution, some technical solution fitting these properties exist? Is it just made up? Is it just a unicorn? Enter the solution of database thin cloning. So what is the idea here? So to draw in a picture, kind of what I mentioned before, we have our production database. Imagine we have this clone. Maybe we don't know how we get this clone yet, but imagine we have this clone of production. Development talks exclusively to that. It's not talking to production. It has a read and write connection to this clone. And for all intents and purposes, for all observable purposes, development thinks it's connected to production because everything looks the same to development from its perspective. And in particular, we'd like to do this scalably. So if we have a lot of developers working at the same time, we want them all to be able to have their own clone, all thinking the same thing. They all think that they have production all to themselves. They can read and write to it. There's no, it works on my laptop but not in prod, because the data is exactly the same. So how do we do this? Really, the magic behind a lot of the solutions in this space, specifically on Postgres, is copy on write, and specifically copy on write cloning in the storage or file system layer. So some examples of just technologies that power this: ZFS, LVM, and I'm not super familiar with Kubernetes, but I've heard there's this thing called OpenEBS you can use that supports copy on write cloning for data. And so what do you do with Postgres specifically to make use of this to power cloning for all of your developers? Well, what you do is if you make sure that PG data, where the file directory, where at the root of where you run Postgres, it holds all of Postgres's data and sometimes all of its configuration as well. You make sure that that's on a file system or storage system that supports copy on write cloning. You run Postgres off of clones that you make. So each time you have a new developer that wants to check out a new clone, basically make a new clone. You bring up a new container. There's some mechanics that I don't want to bog us down with too many details on how you start the server. Maybe you need to promote it. Maybe you need to do some other things. But at the end of the day, you get a connection string. You can give it to development, a development environment by API. End result of this is you have a writable thin clone of the database. It's fast. Suppose you have like a 5 terabyte database. You can clone it in, often, in my observations, as we've adopted this on similarly sized databases at Academia, it might take only 3 seconds, sometimes less. And notably, this is the important thing on the cost side of matters, it only takes more storage overall after writes have occurred, causing clones to diverge. So if, as is frequently the case in development, there haven't been too many writes, usually you don't rewrite the entire database in development. With Postgres, it's good for read-heavy workloads. You're mostly reading. It's just you don't want the page to crash if you click a button, it needs to do one write somewhere. So imagine you have Postgres, you have a clone here. They both are working off fundamentally the same single thick copy of the data, as we'll call it. And the clone has a thin copy of the data. Let's say it does one write just to one block. That's that red block there, not necessarily to scale. And the clone can continue to think, the clone coexists with the main Postgres that is using this data set, and the clone can just continue to think that it has the whole database to itself through this technology. So what are some options? So an interesting thing about this space is that the Postgres ecosystem in particular just has all these different products, projects, and offerings, and I thought I'd mention a few of them. One of them is DBLab Engine from Postgres AI. One of them is Zeta, and so at Academia, we're using both of those right now, as well as also Amazon Aurora. So, starting at Amazon Aurora and down, these are, later down on this list, these are the forks, or things that other than vanilla Postgres will say. Neon, and then I actually had to edit this slide earlier this week because, there's so much recent momentum that Tiger Data, I think just 2 days ago maybe, let out a blog post mentioning how now they support this too. Often in marketing materials for offerings like this, you're going to see this marketed as branching, since I think sometimes, I don't know if like this whole thing is like totally new to some people, or if you already heard a little bit about branching thin cloning, but I think for a lot of people it's not the most intuitive thing to do with a database. Branching is kind of a way to make an analogy with Git. It makes sense, and it makes sense to developers. You can branch a code base, you can open a new branch on a database, and also, you can branch from a branch. But in terms of my opinion, I think the most awesome thing about this is that first branch you make from production. So how does this actually work on the infrastructure layer? What are we actually doing? Do I need to like migrate my database to some ZFS? What if I'm happy where I am right now and I don't really want to make these changes because this one random guy from San Francisco got up on a stage and told me all about it? So there are some options, mostly managed services, that follow the approach of what I'm just making up this term, the native approach, cloning native or branching native. These are where you run your production workload on these services and you create clones directly from production. So these are, Zeta, Neon, Aurora, Tiger Data, I believe, are the ones that fall into this category. But if you're kind of like us and you prefer to leave your data where it is, you don't want to change your infrastructure too much, there is the option of basically just using this specifically for development. So DBLab Engine is the main way you do this with what I call the physical replica approach. And the way that this works is you have your production database. You hopefully are using right now already, if you're running Postgres in production, a backup and recovery solution such as PG Backrest, Barman, or WAL-G. And so for us, our backups end up in S3. What DBLab Engine can do is it can read from those backups. Restore it one time, and then it keeps up to date one additional copy of the data in a separate host, separate infrastructure. It replays WAL to stay up to change. So it's basically, maybe not a streaming replica, but a WAL shipping replica from S3. And every 6 hours, it'll take a new snapshot, and then developers make thin clones off of that snapshot. Some advantages of this physical approach, if you want to keep your data where it is and just use this technology for development only, it has better sync, it has pretty good sync performance, and it lets you replicate the exact state of your database, at least insofar as a streaming replica would have the same state as your primary. Even if your database is corrupt, this will work. Maybe you want to be able to catch that and test that out in dev, test out some fixes, since you should definitely deal with corruption if you have it. So the other approach that lets you keep your data where it is what I call the logical replication approach, where similarly you have new separate infrastructure just for development that will be doing this thin cloning, and you use some sort of logical copy tool, such as pgdump, pgstream, maybe even like pgcopydb. I'm sure there's a lot of others to replicate from production to this, and maybe you set up a logical publication and subscription to keep things up to date, and then you make thin clones off of this logical replica. Some examples in the space are Zeta. In particular, they have these anonymization options. They're currently in private beta, as I understand it, but pgstream has integrations with Zeta's platform, which lets you anonymize data kind of before it reaches the logical replica. And DBLab Engine also has an option for this logical sync mode. And some advantages of the logical approach, obviously there's some things you lose if you use logical rather than physical, like you're no longer replicating the exact internal state of the database, but you get more flexibility and you get, importantly, more options for anonymization in case that is important for your use case. Okay. So what do we use at Academia.edu specifically? Now that I've gone over all this context, how does thin cloning work? How do you set it up infrastructurally? We've been using DBLab Engine, the open source version, using the physical approach for a lot of our databases, in particular everything that we manage ourselves on EC2 instances and have access to the physical backups for. We also have Aurora. Separately from that, we have several Aurora databases. And Aurora thin cloning, just a brief note about that, there are some different characteristics in terms of how long it takes to create those clones. I find that often, like Aurora clones, really for us, that's most useful for testing database upgrades or big infrastructure level work with the database. We're also trying out Zeta, their platform in their closed beta with the logical replication approach. And the thing that's kind of in common, at least with DBLab Engine and Zeta, is that these projects expose an API that lets you request new clones, lets you get connection strings for the clones. And so part of how we put all of this together and make this mesh nicely with a great developer experience for our developers at Academia is we have this script that knows everything it needs to know about our code base, that will call these clone APIs and then template the right config, make sure it's exactly in the format that Rails wants to see, and then gives that, writes that to disk on a developer's local machine, and then there's an envar that you set to enable this rather than the normal Rails config. So you can opt into this. You can also still use the old way if you want for development. Okay, so I am utterly terrified of doing live demos, and also, we have some network restrictions, obviously, on this infrastructure, so I couldn't run these right now if I wanted to. So I'm going to simulate a live demo for you for kind of give you a sense of how this looks from the perspective of a developer. So if you want to check out a new clone, or check out new clones for every single database we have this script in our application repository. We called it dbclone. You pass it like -- all or whatever. This is just a thing we made up. And so, it requests a clone. Clones come in 3 seconds, really fast. So now, let's say I'm a developer, Ruby on Rails shop. I want to poke around in this development environment, see what I can do. So I start a Rails console, load the developer environment. I set, some envar to 1 so that it uses the right configuration. And it's probably going to be somewhat unpopular crowd for this, since I think we don't have high opinions on ORMs, but we're application developers, not DBA. We're wearing that hat. We're going to use the ORM and get the authorship table, what papers have people authored that we're aware of. Let's get the last ID. Of course, like any good ORM, it does select star and then just gives me 1 column. So, there's maybe an upper bound of around 162 million rows in this. Normally in development, you run something like this, you get like 100. Now, okay, so this is an example, this next one. This is an example, it's a little bit contrived, but it is in principle, in theory, something that could come up in development where it works fine in dev and fails in production, which is suppose you want this feature where you get a count of everything and you want to display this on every single page load. Now, this is something that will work performantly in development, but fail in prod. And so, suppose we run this with thin cloning. Select count star from this table. I'll let you know if this query ever finishes. So we've already solved one potential pain point where something would work in dev but not in prod. Now it works in neither, which is good. I'd rather it not work in dev if it's not going to work in prod. Okay, so this is pretty powerful, but let's go over some of the development struggles that we've solved in greater detail. So on the theme of schema differences, I mostly want to talk about partitioning, even though I mentioned there's other sources of drift, but partitioning is one where it's kind of tough to have an answer in development. So suppose we have this table called notifications. It's partitioned by range on the created at column. Pretty common pattern since we want to be able to archive that pretty quickly. We don't want to retain notifications forever. We have some cron job that creates new partitions as they're needed so that inserts don't fail. And what do we do about development if we have a table like this in production? Do we do a cron job in development where every developer needs to separately make sure that cron is working properly, cron is running? Since often with this approach, you end up with a situation where if you have 3 different devs, you have 3 different sets of partitions, including one who for some reason has December already. Maybe local time is messed up or NTP is not working at all for some reason. Do you use a default partition? This is a pattern I've heard some people give mixed reviews about, where it's technically partitioned in development, but it's never going to change. You're just using the default partition. So you might ask, if we're going to do this, why bother at all? Why not just make it a normal table and not partition it at all? That's certainly an option, and honestly, at Academia, this is an option we've done a lot in the past, where we have a partition table in prod. It's just a normal table in dev. The application honestly doesn't care anyways. Rails, if you're using declarative partitioning, the parent table just looks like a normal table, so you can kind of get this to work, but it's not ideal, especially if you're thinking of certain schema changes you might need to make. You'd like to be aware of the fact that the table is partitioned in development. So, best option of all, in my opinion, is just use a thin clone, and it matches exactly, both at the schema level and the data level. Problem solved. Now, on the theme of slow queries, this is frequently a root cause of something that works in dev but fails in prod. It fails in prod because it's too slow, the page crashes or times out. So, what are some of the reasons why a query might be fast in dev and slow in prod? Well, one obviously is because of the scale of the data. Maybe you have a bad query plan, and it's bad even in development, but you don't notice because you don't have a lot of data, so you can get away with a full table scan of the authorships table. Alternatively, maybe you have a query plan, it's good in development, you actually checked that, but in production, just for like certain values or certain circumstances, the query plan goes bad. Similarly, bloat, vacuum, table maintenance issues can cause degradations in performance just on prod, so we'd like to be able to catch that in development, and thin cloning will help a lot with that. A quick note on the specific matter of debugging slow DML, that's modifications, inserts, updates, or deletes. Frequently, this is a thing that has come up for me a lot. I have this delete that's really slow. It's really slow in prod. I cannot replicate it in development. So what do? Well, what I'd really love to do in prod is run explain analyze on that delete. There's a problem though. It'll actually do the delete, and I really don't want that to happen. So this one piece of advice that I will introduce with caution, because, just quick side note, I tried to make sure that this is visually a little scary looking, because I think it's a little scary due to some subtle reasons. You'll see a lot of advice online that you can wrap everything in a transaction, make sure you roll back, and then it's fine to explain analyze, or supposedly this delete statement, capture the output, and then it's as though it never happened, right? If you just roll back. Well, some problems that I see with this approach is fundamentally, even if things don't go horribly wrong, it's not totally consequence-free while that transaction is open, and it's not totally consequence-free after. Some risks are that while you are running that delete, there's still going to be locking. If any other sessions or concurrent transactions need to access that row, there's still going to be wall writes and bloat generated while it's running, and the bloat will remain, at least until auto vacuum cleans it up, even after you roll back. But in my opinion, the scariest thing of all using this approach is that there might be mistakes in your SQL client or your script that you ran. Maybe you end up in auto commit mode when you think you're in a transaction and the delete runs for real. So I'd say clearly, a great use case that I've actually used thin cloning a lot for is you can do a safer explain analyze on data modifications like this. Just check out a clone. Maybe don't even bother with the transaction. Just run it on the clone, and if you want to run it again, check out another clone. Stepping back more broadly on advantages of thin cloning as it pertains to query performance and query performance debugging is sometimes it can be surprisingly difficult. I mean, maybe I'm doing something wrong maybe Ruby on Rails is doing something wrong, but sometimes it can be very hard to know exactly what the query is that's slow. Like we have a report, a page is slow, but what's the query? What's running? Well, we have this ORM that makes it hard to look at the code and answer the question. Maybe you'd expect our monitoring solution to tell us, but sometimes it's sampled for, again, cost-cutting reasons. Sometimes they've helpfully anonymized the query, and I can't, I need the exact values in the predicate to tell why, find a thing to explain analyze. Or, even if you're not using an ORM, I'm sure there are query builder frameworks and statements that get constructed at runtime where it can be kind of hard to figure out just by looking at the code what the query is. So a great thing about cloning that's just available to use in dev is you can just go to the development web page that corresponds with the production one that's slow, see it slow, maybe tail the development log and see what query is running that is holding everything up, and things work great. It's also great for testing a fix before prod. I like using this image because it's on the Wikipedia page for Rube Goldberg machines, and it's public domain. The query planner can be a little bit complicated sometimes, and so often if I'm debugging in prod a query performance problem, I feel like I'm throwing spaghetti at the wall on my production system, and it's not a great experience. It's a lot more fun to be able to test my fixes on development, so I have confidence that it'll actually work by the time I'm touching prod. Okay, now I'm going to talk about the team in particular where this has helped us, I think, arguably the most, and that is in context where we have a 0 to 1 product. So Academia's core product, as I mentioned before, is you're an academic, you publish somewhere, and then at some later point in time, you want to upload what you've published to our site. We'll make it available for everyone to read. We'll give it greater reach. What if we, the product minds at my organization were thinking, what if we cut out that intermediate step and let people publish directly with us? And some of the motivation here is that the current state of publishing is not great. In particular, it's slow. It's stuck in the 17th century. We have the internet age. So really, we want to speed things up. How do we do that? Okay, so let's build a publishing product. How difficult could that possibly be? Narrator speaks very. So here's my idealized state machine for what I would think a publishing pipeline should look like. You need a manuscript pipeline. Someone submits a manuscript. They're hoping to get it published with you. You're an open access publisher. You go through several stages, like a desk check, make sure it's good enough to even send to reviewers. And then there's several rounds of peer review. And then finally, we make a decision. It either gets published or rejected. Simple enough, right? Let's look at just this revise and resubmit workflow. So I simplified this diagram to make it fit on the slide, but in reality, everything is just utterly, completely complicated. I had to remove some of the arrows of the state transitions, and just thinking of this product's context, if our goal is to move fast, it's a big problem if something gets stuck in one of these states because there's a bug in the code that's supposed to power one of these arrows in this mess of a diagram. Another important piece of context here is that we have an engineering team based largely in San Francisco that's changing a little bit over time. We have an editorial team. The editorial team handles a lot of just the non-coding parts of managing a journal. They're largely based in Europe. And needless to say, things just move a lot quicker if the development team is able to just replicate on their own problems that the editorial team has run into without needing to always overlap hours and ask them for clarification and ask them for help replicating it. So thin cloning, at the end of the day, thin cloning has been revolutionary for us, particularly for that team, but also for all the rest of us too. It's been revolutionary in helping us replicate complicated bugs. It makes developers more aware of performance issues and query performance in development before they push it out to prod and start causing site performance issues. And above all else, it helps us iterate a lot faster. So if, maybe some of you are thinking, okay, this sounds kind of cool. I want to adopt it, but what's involved with that? Well, challenges and advice section here on some learnings that we've had in setting this up for our developers. One thing that we learned pretty early on is that latency is really key. In production, the database and application layer live in the same region in AWS, and this is a thing we didn't quite realize the importance of at first, which is that you have a single HTTP request that goes into your server, even in development, and then there's going to be a lot more than one query on certain pages that need to read and write to a database from development. And so what this means is that it's really important to make sure that the database, whether it's a clone or just any database in general, lives in the same region as the application that is talking to it. We were hoping that maybe we could optimize costs by keeping all the data in US East 1, and development could send a relatively smaller amount of data between the development and the cloning infrastructure. Didn't quite work out. We're happy to pay the cross-region transfer costs if it means devs are happier, though. All right, so on a broader theme of performance when using the system, okay, what's the catch? That sounds amazing, but what's the trade-off here? Well, if you have the data set of prod, but we want to save money, run on economical hardware, we have less compute power, less memory than prod. Certain developer workflows are going to be a bit slower. They're going to be a bit slower than if you just use normal local databases on dev, albeit with smaller data sets that don't really reflect what's in prod at all. It's going to be slower than prod as well. It's definitely worth it, and I say that as someone who has measured revealed preferences, keeping track of who's actually using this day to day. On a similar note, if your goal is benchmarking specifically, like you're running pgbench, we don't do that a whole lot at Academia. Most devs are more focused on kind of product behavior and does the page load. But if you're running pgbench because there's some performance aspect of more core to Postgres that you're looking into, then clones are obviously not ideal if you have this copy on write structure that doesn't necessarily reflect how you're really running in prod. And similarly, there's a little bit of tuning we needed to do with, this is like DBLab Engine specific, since that one's using ZFS and we manage that. We needed to make the record size a little bit smaller on one database that had pretty high write throughput, just to make sure it could keep up with wall replication. So I think a big part of the challenge of something like this is that we have data in certain other places besides Postgres. I list a bunch of things here, but in particular, we have documents. People upload papers they've written. So we have documents. We store those in S3. I've heard it's probably not a good idea to use large objects or whatever options you have for storing that in Postgres. Not your most performant option. It's better to store that in something that optimized for that, like S3. And so we have a lot of tables that will have file name columns, and that will be through a combination of our application configuration and the data in that table, it'll point somewhere in S3. Okay, so how do we deal with this if we have this clone that's pointing to production now? We have development. Obviously, we're not giving development blanket access to prod versions of all these resources. So this can be a little bit of a challenge. It means certain things like try to load this file and it just doesn't work, at least out of the box. Obviously, this is going to require, if some of this is resonating with you, like, oh yeah, that's definitely something that applies in my organization as well. I wish I could tell you better news than it's going to require some custom workarounds in your code. That's part of what that environment variable does for us that we set that I mentioned earlier, is it doesn't just point at a different config. It also says okay, enable these workarounds so that we do something sensible for S3 or make it not crash at least. So you need to do some things that are intentionally different from prod, unfortunately. The good news is, at least for us, maybe your mileage will vary, the Pareto principle, 80-20 rule, definitely applies in our experience here. You really only need to fix 20% of these things to get 80% or more of the benefit, maybe even less than 20%. So I'd recommend just have an issue tracker if you adopt this and run into anything like this. Try and fix the things that people point out the most, and that's worked out pretty well for us. So a little bit of notes on PII and compliance, since I promised I'd talk a little bit about that, and some of you are probably a little bit concerned, okay, this is a non-starter for me. PII, I cannot expose that to development. So there's a couple of broad approaches you can take to address this. I'd say it's still solutions in this space to this problem are still evolving, and I'm excited to see different approaches here. But one is just treat dev more like prod. Lock down access to dev, control that environment more tightly, and also if you have a DB that even in that context is still too sensitive, maybe skip that one for now. Use the one that doesn't have all the PII in it if you have that split into multiple databases. So we definitely use this approach a lot at Academia to make this work for us. The other approach, where we're increasingly seeing more momentum here, is what I call the data anonymization approach. So that would be, like I mentioned before, with the logical plus anonymization approach, where the logical syncing method, somewhere in there, you anonymize it while it's in transit and make sure that it doesn't even hit dev with any PII. pgstream is something that has a way you can enable that. And then the other approach, if that for some reason doesn't work, in particular, if you really want to be able to have a physical equivalence in your data layer, the other approach that is possible is there's an extension called Postgres Anonymizer. I believe you create it with create extension anon if it's installed, and it supports this option called dynamic masking, which can let you define rules for certain on a role-by-role basis. And I think right now it would require it requires a little bit of work to set this up. You need to probably patch some things about whatever framework you're using to actually turn this on. But yeah, excited to see more development in this space, since I do think this is an important problem. They're both important problems, making sure development matches prod, but making sure it doesn't actually completely match prod. We want to be compliant and responsibly handle PII. Okay, some closing thoughts. So I tried to find a good answer to like why, we have all these options in Postgres. I mentioned there's these pain points in other databases that we use, like Elasticsearch, Redis, S3. Why is it that there's so many solutions in Postgres and it feels like there's not a whole lot in other databases or, MySQL as well? So I like struggled. I really couldn't figure out any clear technical reason for this. Maybe there's someone who's a lot more familiar with Postgres internals than I am, who can point to something like, something about the wall or the format on disk helps. I think really like my interpretation of this is that it just speaks positive things about the Postgres community and the ecosystem and the strength therein right now, that you just have all these people doing cool things with Postgres right now. I think that's great. I love Postgres. I do wish I could use this on every single database, if possible. But to wrap it all up in summary, I mean, thin cloning was really a game changer for us. It helped us out a lot. And if I've managed to convince any of you that maybe this is something you might want to try out, I hope it will be for you as well. With that said, thank you so much for listening to me this early in the morning. I'd really appreciate any feedback you have. You can use that QR code, or I think that link should be equivalent, and be happy to take any questions. Thank you.
If I got that right, you're using not plain Postgres, but Postgres forks. If I got it right, because you do that cloning or copy on write on the database level. Is there any strong reason why this couldn't be done with plain Postgres and say a copy on write file system?
So the question, just to restate the question to make sure I got it right, why couldn't this be done with plain Postgres? Sorry, I'd like to clarify this just in case it was unclear from the presentation. We are using plain Postgres, at least in context other than using Aurora cloning, since that's technically not plain Postgres. DBLab Engine and Zeta, they both use plain Postgres. They're just swapping out the storage layer under the hood. So it can be done with plain Postgres. I know that because we are doing it with plain Postgres. Yeah. So hopefully that answered that question.
So I'm not familiar with these technologies at all, so please bear with me when I ask the question. How long does it take you to create the clones? I get 3 seconds. That makes sense. I understand why. How long does it take to create the principle that the clones come from?
Oh yeah. So just to state the question again, make sure I understand it. Once you have the single, suppose you're not using like native, since there aren't really any, I don't think there's any like fully open source options for native where you actually run prod on this. You're using the have another copy of it just for development approach. How long does it take to bootstrap or initialize the first thick copy? And then after that, everything is good, but how long does it take? I'd say it depends on whether you're using the physical or logical approach. Obviously, physical is, like in many contexts, it's going to be a lot faster than logical. I think of several terabytes per hour potentially, if you really tune everything right with, a PG backrest restore. We use PG backrest. Logical, I think of, I wish I had the same time unit here, but I think of gigabytes per minute. I'm often impressed if I get more than 1 gigabyte per minute with logical syncs, which is, I think if I do the math, it's a lot less impressive performance-wise than terabytes per hour. Maybe someone has a calculator. I don't want to do mental math right now. Yeah, but I'd say maybe if you're doing the physical approach, how long does it, if you have a sense of how long it takes for a restore of your backup solution, it's going to be maybe comparable with that. There's obviously some things that are a little harder to tune if you're using this framework. Frameworks in general can be a little opinionated. They might not be absolutely optimally tuned with all the settings. So generally though, it's pretty bearable, and once you sync once, it can stay up to date.
Okay, then the follow-up would be, how often do you reset that?
Okay, so the question on how often we reset it. So for the physical approach, the way that works, and it's worked out pretty well. We don't. The short answer is we don't often have to do a full reset with physical, because it continues to just pull WAL files from S3 and update like the main thick copy of the data on the fly. Every once in a while, at least with like DBLab Engine, it will make a snapshot of that, and it will, you know, it'll actually retain several snapshots at once. And so, yeah. So the short answer is, if you need to reset it, it's going to be the same as like initializing it, but often that shouldn't be necessary. And then a quick note on like the logical option as well, since on Zeta's platform, that's their focus. I haven't actually tried out the create a logical subscription option, but that's definitely an option for logical too, where, you know, with logical, it's particularly painful to sync everything the first time, but once you do it once, assuming you can keep that logical subscription working, can be a little tricky sometimes to do that too. That should hopefully prevent some of the pain of having to like resync on some cadence. Well, all right. Thank you all once more for attending.